Alright guys, I'm going to start out this video with working through problems 1, 6, and 7. Number 1 is just simplifying the radicals, while 6 and 7 we are factoring. So, in order to simplify the first radical, we do know that whatever we bring out from under the radical has to be multiplied by that 2 that's already on the outside. So I'm going to think of any two numbers that multiply to give me 32. Off the top of my head, I'm thinking 8 times 4. It does not have to be these two numbers, it just has to be two numbers that multiply to give you 32. Then 4 is going to be 2 times 2, which the 2's are prime numbers, so I'm done there. 8, we know is not prime, it's going to be 4 times 2. Sorry guys, my pen's kind of working, but not really. And then here, the 4 would be 2 times 2, okay? So, I cross out everything I have broken down. I have a pair of 2's here. I have a pair of 2's here. And I'm left with this little 2 right here. So I bring out from under my radical because 2 times 2 is 4. The square root of 4 is 2. That's the whole reason we circle perfect pairs, because they are perfect squares. So I bring out 1, 2 from one group, then I need to multiply another 2 from another pair of 2's, and then we have 1, 2 that's going to be left under that radical. So to simplify, you have 2 times 2 times 2, which is 8. 8 root 2 would be your answer. Sorry if you hear my dog breathing, he was just running outside, so. Alright, moving on. Number 6 and 7, these are solving by factoring, okay? So, we've got to think, do you have binomials? Do you have trinomials? What am I working with here? Both of these are binomials. So I've got to make sure I'm set equal to 0, which I am, and I've got to look for the GCF, okay? Which both of these end up having GCFs. If I look at number 6, they both have in common a 2. Okay, I can take out a 2 as the GCF. And then they both also have x's. And remember, your GCF is not always just numbers, it can be variables as well. So I'm going to take a 2x out. That means each of these I'm going to be dividing by 2x. Okay? And that leaves me with x minus 5. Alright, and remember to check yourself. If you multiply or distribute that 2x back through, you should end up with what you started with. Now, this is one of those nice, unique cases where when I take out my greatest common factor, it factored for me because I got rid of that x squared term. So, I know my two factors of this are going to be 2x, so I'm going to set that equal to 0 to solve, and x minus 5 is equal to 0. Do not get rid of your greatest common factor. He cannot go anywhere until you divide him out. To solve for x over here, I'm going to divide by 2, so x is going to equal 0. And here I'm going to add 5 to both sides, and x is going to equal a positive 5. Those are my two solutions for these. Now, number 7 is slightly different. Now, I do have a GCF. I'm set equal to 0, so I'm good with that. That's check. But I do have a GCF. The GCF for this one is 2. I cannot bring out an x because both of these two terms, the 2x squared and negative 32, neither of them have not both of them have an x. Only the 2x squared has an x in it. So, I'm going to be left with, if I divide both of those by 2, you're going to be left with x squared minus 16 is equal to 0. Now 16 is a special number because it is one of my perfect squares. If you don't know your perfect squares, 2 is not a perfect square. Please hold. I'll go ahead and 2 is not a perfect square. What I meant to say switch back to my pen. Hold on. Wait for it. We have 1, then 4, 9, 16, 25, 36, 49, 64. We have, that's 8 squared. 9 squared is 81, 100, and so on. 121. That's all I can fit for now, so I'm going to stop there. Make sure you know these. We know this is a difference of square because 16 is a perfect square. In between the x squared and 16 is a subtraction sign, so that means it is a difference. So that factors to become, if I try, let me change colors for this one. This, we would take a square root. So we end up having the square root of x squared is x. So I'm going to have an x times x. And then the square root of 16 is plus or minus 4. Okay? That doesn't really look like a 4. Ooh, that's so ugly. Let me rewrite this for us. So, sorry, my dog's really panting. I can't help it. That's a little bit better. So, the 2 technically can be divided out. It does not have an x like we had in this guy over here. That's why he was part of a factor. We had 2 separate factors here. 2 can actually be divided out and only leave me with my 2 factors inside of my parentheses, which are x plus 4, and I'm going to set him equal to 0, and x minus 4 is equal to 0. So both of your x's, once you solve for x's, you should get x is equal to positive and negative 4, also known as plus or minus 4. Okay? There we go. And that's it for those binomials. In the next video, I am going to be doing a trinomial and completing the square.